Good day, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, I'm going to be taking you through the inverse matrix method of analyzing or solving simultaneous equations involving three variables. Yes, let's get started. Now, we are going to design our question and we'll solve it from the beginning to the end using the matrix inverse method. Yes, so now I'm going to take my x, my x to be equal to 1, y to be 2, and z to be equal to 3. Yes, I'm actually using this to design my question. So I will use this to design the question, and we're going to use the inverse matrix method to analyze the question. Now let's look at question equation 1. Now, given that we have x plus y plus z will be equal to, now we're adding the 3. So this is 5 plus 1, that is 6. So it's equal to 6, equation 1. Yes. Now let's do a 3x plus 2y minus z. Yes. 3x is 3 times 1, which is 3. Then plus 2y, that is 2 times 2. That will give us 4. Then minus 3. So that will be equal to 4. So this here we have 4. Equation 2. Yes. Now equation 3, let's look at 6x minus 5y plus 3z. Yes, let's see what this will give us. 6x, that's 6 times 1, which is 6. Yes, 6 times 1 is 6. Minus 5 times 2 is 10. Then here we have plus 3 times 3 is 9. Yes, so 6 plus 9 is 15. And 15 minus 10 is equal to 5. Yes, 15 minus 10 is 5. So here we have 5, equation 3. Now the question is, using matrix, yes, or let's call it inverse matrix method. Inverse matrix method. Yes, find x, y, and z. Yes, x, y, and z. Now, if you look at this now, remember we said the value of our x now, let's put it here. The value of our x is 1, the value of our y is 2, and the value of our z is equal to 3. Yes, that is how they design simultaneous equations. Yes, now we have seen the question now. We want to solve for x, y, and of course z. Yes, x, y, and z. So now in this case, solution using matrix method. Yes, using the matrix method. Now, using the matrix method, the first step is to arrange the coefficients of all the variables. Yes, now let's arrange. Let's do that. Now, in this case, we have here, there's nothing here. It means we have a hidden one there. The coefficient there is 1. So we have 1, here we have 3, and here we have 6. Here we have 1, here we have 2, and here we have minus 5. Here we have 1, here we have minus 1, and here we have plus 3, which is same as 3. Yes, I remember here we have x actually came before y, so we have x, we have y, then z is equal to, here we have 6, we have 4, and 5. Yes. Now this is the first step, arranging all the coefficients. Yes, now you can see that we have arranged all the coefficients. Yes, so the next step, now the next step is this now. Let's look at this now. Like for instance, if you have 5x is equal to 7. We know the value of our x here is the same as 7 over 5. And the 7 over 5 is the same as saying 1 all over 5 times 7. Yes, 7 over 5 is the same as 1 all over 5 times 7. And here, our x is the same as this 1 over 5 is 5 raised to the power of minus 1. Then here we have time 7. So it's also applied to matrix. Yeah, it's also applied to matrix. Now, in this case, x, y, z will be equal to the whole of this all over this. So we have, yes, let me take it to the other side. So x, y, z will be equal to this over this. So we have 6, 4, 5, divide by the matrix We have 1, 1, 1. We have 3, 2, minus 1. We have 6, minus 1, and 3. Yes, the whole of this. And of course, this is the same as saying x, y, z will be equal to 1 all over. We have 1, 1, 1, 3, 2, minus 1, 6, minus 5, 3. Yes. Then here we have times 6, 4, and 5. Yes, times 6, 4, 5. So now this one all over this matrix is the same as saying x, y, z will be equal to, we have 1, 1, 1, 3, 2, minus 1, 6, minus 5, 3, inverse. Yes, inverse. Then we have times 6, 4, and 5. Yes, that's x, y, z. Now, I want us to look at the inverse of this matrix. Yes, that is inverse of a matrix. So now, first of all, let's assign a variable to that particular matrix. Yes, let's assign a variable to that matrix. So here, let A be equal to, we have 1, 1, 1, 1, 1, 3, 2, minus 1, 6, minus 5, and 3. Let A be equal to this matrix. Yes. Now, A inverse. A inverse, the inverse of a matrix is 1 all over the determinant of that matrix, yes, times the adjoint or cofactor of the same matrix or transpose. Yes, when you transpose the cofactor of a matrix, it actually gives the adjoint of that matrix. So it therefore implies that this cofactor of A transpose is the same thing as the adjoint of matrix A. Now, let me put it there. A inverse is 1 all over the determinant of A times the adjoint of A. Yes, times the adjoint of A. Yes, this is the adjoint of A. Now, let's start with the determinant of the matrix. Yes, because here you can see that we have to calculate for the determinant of the matrix. We have to calculate for the cofactor and transpose the cofactor to get the adjoint of the matrix. So now let's look at the determinant. Now, determinant of matrix A is a determinant of 1, 1, 1, 3, 2, minus 1, 6, minus 5, 3. Yes, determinant. Now, in our last section on matrix, we actually looked at how to calculate for the determinant of matrix using two methods, the cofactor method and the Cyrus method. Yes, cofactor and Cyrus method. So here we are going to be using the cofactor method. I remember I did say that if you're using the cofactor method, you have to bring out the signs. Yes, the signs we have plus, minus, plus, minus, plus, minus, plus, minus, plus. Yes, because we are dealing with 3 by 3. And I also mentioned that you can use any of the rows. You can use any of the columns, but you are not allowed to use the diagonals. Yes, when I say diagonals, you can't use it this way, but you can use any of the rows or any of the columns. So I want us to use this. Yes, I want us to use the first row. Yes, so if you're using the first row, it means the determinant of A now will be the determinant of this. So you pick the first plus. So we have it as plus. Yes, that plus actually tallies with this number here, 1. So you have 1, you open. Now you close 1 in the column, you close it in the row. So we have 2, minus 1, minus 5, and 3. Yes. So you go to the next sign. The next sign is minus. So you pick the minus. It actually tallies with this one here. Yes, it tallies with this one. So you take the 1 out. So where you pick the 1, you close the 1 in the column, you close it in the row. So we have 3 minus 1, 6, 3. 3 minus 1, 6, 3. Then lastly, we have plus. So we pick plus, it tallies with this 1. So you bring out the 1, you open, you close the 1 here, you close it here. You close it here, you close it here. So we have 3, 2, 6, minus 5. Yes, yes. So it means the determinant of matrix A will be equal to, here we have 1 in brackets. Remember for 2 by 2. Yes, I told us that to calculate for the determinant of a 2 by 2 matrix, you can use the Saros method, that is the product of the principal diagonal less the secondary or the minor diagonal. That is your left hand. This times this minus this times this. I take it again, your left hand. This times this minus this times this. So now it means in this case, 3 times 2, 2 times 3 is 6. Minus 1 times minus 5 is 5, because minus times minus is plus. So here we have 5. Minus 1 in brackets. 3 times 3 is 9. Minus 1 times 6 is minus 6. Then here we have plus 1. 3 times minus 5 is minus 15. Minus, yes, it's minus 15. Take notes. And 2 times 6 is 12. So here we have 12. Yes. So it therefore means that here, the determinant of A, will be equal to, yes, it will be equal to, we have 1 in brackets. 6 minus 5 is 1. So here we have 1. Minus 1 in brackets. 9 minus minus. Now let's look at this. Minus minus will change to plus. Yes, because minus times minus is plus. So 9 minus minus 6 is 9 plus 6. And that will give us 15. Yes, that will give us 15. Then here we have plus 1 again. Now minus 15 minus 12. That will be minus 27. So here we have minus 27. So it means the determinant of A will be equal to 1 times 1 is 1. Minus 1 times 15 is 15. Plus times minus is minus. Then we have 27. So the determinant of A will be equal to, yes, 1 minus 15, 27. That is 15 plus 27. So this is 12. That's 42. So 1 minus 42. Yes. So it means the determinant of A will be equal to minus 41. Now let's take note of this. Yes, let's take note of this. The determinant of A is minus 41. So it means this determinant is out. So the next thing here, the next step is to get the cofactor. Yes, it's to get the cofactor. Now remember we said it is when you transpose the cofactor of a matrix that it actually gives you the adjoint of that matrix. Okay, so now let's look at the cofactor of A. Now the cofactor of A. Now remember we are still using the cofactor sign. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Now let me circle it here. Yes, plus, minus, plus, minus, plus, minus, plus, minus, plus. Yes, because in this case, we're actually restricted to 3 by 3. So if you have 4 by 4, it means you have to add minus, plus, minus, then you form another row. Okay, in the same order. Now, cofactor of A. Now, we are going to use all the signs. Now, remember in determinant, I said you can use any of the rows, either this, or this, or this. Any of the rows or any of the columns to calculate for determinant. Yes, but for cofactor, you are using all the signs. Yes, you are using all the signs to calculate for the minus, all the signs. So it means in this case, let's see the first sign. The first one is plus. So we have plus. Now, in this case, you are not bringing out any number like the case of determinant. Remember, when we pick plus there, we say it tallies with 1. We brought that 1. Yes. But in this case now, for cofactor, you are not bringing out any number. Yes. It's just to admit, to acknowledge that it actually tallies with 1. So now, you close the 1 in the column, you close in the row. We have 2 minus 1 minus 5, 3. So here we have 2 minus 1 minus 5 and 3. That's for the first one. Yes. Yes, I'm using comma to separate the members, the elements. Yeah, it's not a chain like that of determinants. Yes. Now the next one now is just minus. Just minus. So now we pick the minus. You pick minus. Yes. Remember I say you're not bringing out any number. The minus there, look at it. Just minus. It tallies with 1. You close 1 here, you close it here. We have 3 minus 1, 6, 3. Yes, 3 minus 1, 6, and 3. Yes. So lastly, we have plus. Yes. Yes, I'm referring to this plus now. This one here. So the plus actually tallies with this one. So you close the 1 here, you close it here. You close the 1 in the column, you close the 1 in the row. We have 3, 2, 6 minus 5. We have 3, 2, 6 minus 5. Yes, 326 minus 5. 326 minus 5. So we are done with the first rule. Now we're going straight to the second rule. Now for the second rule, you pick minus. Yes, you pick minus. And if you look at the position of that minus, this minus, that is where you have 3. Yes, that's where we have 3 there. So now you close the 3 here, and you close the 3 in the row. So we have 1, 1, minus 5, 3. 1, 1, minus 5, and 3. Yes, so the next one will be plus. Yes, the plus actually tallies with 2. Yes, let's say it tallies with 2. So you close the 2 here in the column. You close the 2 in the row. Yes, so we have 1, 1, 6, 3. So we have 1, 1, 6, 3. Now lastly, we have minus. Yes, the minus tallies with this minus 1. So you go to the position of that minus 1. Yes, we are here now. This minus. It tallies with this minus 1. So you go to the position of the minus 1. You close the minus 1 here. You close it here. So we have 1, 1, 6, 5. Yes, 1, 1, 6, and minus 5. Sorry, this value here is minus. Yeah, it's minus. It's minus. So now, let's begin it again from the beginning. Yes, you pick plus. The plus tallies with 1. You close this, you close this. We have 2 minus 1 minus 5, 3. Good. The next one is minus. It tallies with this. You close this, you close this. You have 3 minus 1, 6, and 3. That's good. The next one is plus. Tallies with this. You close this, you close this. We have 3, 2, 6 minus 5. Yes. So now we are here now. The minus tallies with 3. You close the 3 here, you close it here. You have 1, 1, minus 5, 3. Good. The next one is plus. The plus tallies with 2. You close it here, you close it here. You have 1, 1, 6, and 3. Good. Then lastly, we have the minus. Yes, where we actually stopped. Now, minus. The minus tallies with minus 1. So you close the minus 1 in the column. You close it in the row. So we have 1, 1, 6 minus 5. 1, 1, 6 minus 5. So here we have 1, 1, 6 minus 5. Yes. Yes. So here now, we continue here. That's plus. Yes, so we're here now. That's this plus. So the plus actually tallies the 6. Yes, looking at the plus there, it tallies with the position of 6, number 6. So here, you close the 6 in the column. You close the 6 in the row. We have 1, 1, 2 minus 1. So you read it out. 1, 1, 2 minus 1. Yes. I take it again. You close the 6 here. You close it here. 1, 1, 2 minus 1. Then you go to the next sign, which is this minus. So you pick the minus. Yes, you pick the minus. The minus actually tallies with this minus 5. So you close the minus 5 here and you close it here. So we have 1, 1, 3 minus 1. 1, 1, 3 minus 1. Yes. Then lastly, we have plus. Yes. And the plus tallies with this plus 3. So you close the plus 3 here, you close it here. So we have 1, 1, 3, 2. 1, 1, 3, and 2. Yes, 1, 1, 3, and 2. Now, it means the cofactor of matrix A now will be equal to... Now, let's look at this now. Remember, for 2 by 2, you see these two straight lines actually designates determinant. Yes, that is why you don't have to use the bracket like this. It has to be 2 straight lines. Yes, designating determinant. Yes. So now for 2 by 2, I said is the product of the principal or primary diagonal less the minor diagonal. That is, this times this, your left hand. This times this minus this times this. Yes, your left hand. This times this minus this times this. So here, it means here we have 2 times 3 is 6. 1 times 5 is 5. Yes, minus 1 times minus 5 is 5. So 6 minus 5 is 1. So there we have 1. Now let's look at this now. Here, we have 3 times 3 is 9, minus 1 times 6 is minus 6, and 9 minus 6 is 15. Yes, that's 9 plus 6. But if you look at the front, there's minus there. So this is minus 15. Yes, it's minus 15. Now the next one is 3 times minus 5 is minus 15, minus 2 times 6 is 12. So that gives us minus 27. Yes, minus 27. Now the second row, let's look at this now. Here we have 1 times 3 is 3, minus 1 times minus 5, that will give us minus 5. And minus will change to plus. And 3 plus 5 is 8. But if you look closely, you discover that there's minus at the front. So it becomes minus 8. Yes. Now the next one. 1 times 3 is 3. Minus 1 times 6 is 6. So that will give us minus 3, because 3 minus 6 is minus 3. So here we have minus 3. Yes. Now the next one, we have 1 times minus 5. 1 times minus 5. Yes. 1 times minus 5 is minus 5. Yes. And here we have 1 times 6 is 6. Yes. Minus 5 minus 6, that will give us minus 11. So if you look at the front there, yes, before the brackets, we have minus sign. So minus minus is plus. So that will change to plus 11. Yes, plus 11. Now let's look at this now. 1 times minus 1 is minus 1. Yes, this time this is minus 1. Then minus. This time this is 2. So minus 1 minus 2 is minus 3. Yes, it's minus 3. Now the next one now. Here we have 1 times minus 1 is minus 1. Yes, 1 times minus 1 is minus 1. Minus 1 times 3 is 3. So that will give us minus 4. Yes, minus 1 minus 3 is minus 4. But there is minus at the front. So minus minus 4 will give us 4. Yes, minus minus 4 will give us 4. The minus sign will go. So here we have 1 times 2 is 2. Minus 1 times 3 is 3. So that will give us minus 1. Because 2 minus 3 is minus 1. Now, this is the cofactor of the matrix. Yes, this is the cofactor of the matrix. So now let's spell it out. The cofactor of matrix A is equal to, we have 1 minus 15, we have minus 27, here we have minus 8, we have minus 3, and we have 11. Here we have minus 3, we have 4, and we have minus 1. Yes, minus 1. So this is the cofactor. Yes. Then remember this now. Remember this relationship. Yes, let's look at this relationship. We said the inverse of a matrix is 1 all over the determinant times the adjoint of the same matrix. So it therefore means that to get the adjoint, we said the adjoint of matrix A is the cofactor of matrix A all transpose. So it means the adjoint of A will be equal to this matrix. That is 1 minus 15 minus 27 minus 8 minus 3 11 minus 3 4 minus 1 all transpose. Yes, all transpose. So it means the adjoint of matrix A now will be equal to, now when you're transposing the matrix, the position of the column, the first column will change to the first row, the second column will change to the second row, and the third column to the third row. Or you hold it this way, your left hand up, you turn it like this, you hold it, you turn it. So now the first one, I'll hold it this way, I'll turn it this way. Yes, so I have 1 minus 8 and minus 3. Now the second one, you turn it this way, we have minus 15 minus 3 and 4. Then the third one, you turn it this way, you have minus 27 11 and minus 1. So now this is the adjoint of the matrix. Yes, that's the adjoint of the matrix. So now we want to see the value of our x, y, and z. Yes, x, y, and z. X, y, and z. Now remember what we said about x, y, and z here. Now let's figure it again. Let's figure it again. We said x, y, and z is the inverse of this matrix times this value. Yes, we said A. Remember we said let A be equal to the matrix. Yes, A is 1, 1, 1. We have 3, 2, minus 1. We have 6, minus 5, and 3. Yes, we say let A be this. And we now concluded that the A inverse is 1 all over the determinant of A times the adjoint of matrix A. Now we have all these elements. Yes, we have the determinant to be minus 41. We have the adjoint to be this. So it means the value of our x, y, and z. Now let's look at this now. Let's flash back to this. So our x, y, and z will be equal to, yes, we have this inverse now, which is 1 all over the determinant minus 41, yes, times the adjoint, yes, times the adjoint of the matrix. Now the adjoint is 1 minus 8 minus 3 minus 15 minus 3 4 minus 27 11 and minus 1. Yes, this is the inverse. Then times, we have 6, 4, and 5. Yes, 6, 4, and 5. So here now, to get the value of x, yes, to get the value of x. Now remember multiplication of matrix. You can still watch my video on multiplication of matrix. Yes, to understand this better. So to get the value of x, x is actually the first one here. So you're dealing with this now. So we have 1 times 6 plus minus 8 times 4 plus minus 3 times 5 divided by minus 41. Yes, let's take it again. This, remember we said multiplication is row by column. So it's this times this plus this times this plus this times this. So here the value of our x now will be equal to 1 times 6 is 6 minus plus. Here we have minus 32, then plus, then here we have minus 15, all over minus 41. So this is the same x is equal to 6 plus minus is minus. Minus 32 minus 15 divided by minus 41. So that will give us now, let's look at this now. This is like saying 6 minus 47. Yes, let's look at it again. 6 minus 4, because minus 32 minus 15 is minus 47. So 6 minus 47 all over minus 41. So it means the value of x, yes, it means the value of x now will be equal to, yes, the value of x will be equal to 6 minus 47, which is minus 41, all over minus 41. And we know minus divided by minus will change to plus. 41 divided by 41 is equal to 1. So the value of our x is equal to 1. Yes, so let's get the value of our y. Let's get the value of our y. So y now will be equal to, now remember here, y is the second one. So you go to the second rule. Yes, so you go to the second rule. So here we have minus 15 times 6. Yes, plus we have minus 3 times 4 plus 4 times 5 all over minus 41. So it means here y will be equal to minus 15 times 6. 15, 6, this is 30, so that's 90. Minus 90, then here we have plus minus 12, then here we have plus 20. All over minus 41. Yes, all over minus 41. It means the value of our y will be equal to minus 90 minus 12 plus 20 all over minus 41. Yes, so this is the same thing as saying minus 20 minus 90 plus 20 is minus 70. So minus 70 minus 12 all over minus 41. So that will give us minus 82. Yes, because minus 70 minus 12 is minus 82 all over minus 41. So minus minus will change to plus. So the value of y will be equal to 82 divided by 41 is 2. Now let's take note of those values. Now y is 2, and here we got the value of our x to be 1. Yes, x is 1. So now let's see the value of z. Yes, let's see the value of z. Now the z is the last one there. Yes, z is the last one. So let's see the value of z. So the value of z now will be equal to, yes, z will be equal to, now let's do it from here. Z is the last one. So it means we're dealing with this rule. So it will be minus 27 times 6, minus 27 times 6, plus, yes, 11 times 4 plus minus 1 times 5, minus 1 times 5. Now all over minus 41. It means the value of z will be equal to, now let's see 27 times 6. 27, 6 times 7 is 42. Yes, 36 plus 6, that's 42. So here we have 2, 4. Then 6 times 2 is 12. 12 plus this, that's 12 plus 4, that's 16. So here we have minus 162 plus 44. Then here we have minus 5, because this plus will change this minus to minus. Yes, plus minus is minus. All over minus 41. So it means the value of z now will be equal to, now let's see, 162 minus 44. There is 12. 12 minus 4 is 8. There is 5. 1. That's minus, yes, minus 118 minus 5. Yes, minus 118 minus 5. Okay, so in that case, minus 118 minus 5 all over minus 41. So it means the value of z now will be equal to, yes, the value of z now will be equal to, let's see, 118 plus 5. 118 plus 5, that will be, here we have 3, that's 13, so here will be 2, and here will be 1. So 123. So we have minus 123 divided by minus 41. Yes. Now let's see, 41 times 3, this is 3, and this is 12, okay? So here, this minus will change to plus. So 123 divided by 41 is equal to 3. So therefore, x is equal to 1. Yes. Y is equal to 2. Y is equal to 2, and z is equal to 3. So this is the inverse matrix method of solving simultaneous linear equations involving 3 variables. Now remember, our initial value of x, we took x to be equal to 1, y to be equal to 2, and z to be equal to 3. So this is the method or the steps in applying to apply when solving simultaneous equation involving 3 variables using the inverse matrix method. So thank you so much for watching. Watch out for more videos on the determinant method, which is the Cramer's rule. Yes, in our next section, we're going to look at the Cramer's rule and also the Gaussian elimination method. So thank you so much for listening. Remember to like, share, and subscribe. God bless you.